Okay, well, let's graph y versus t. Okay? The square root of, well, we don't need the square root. The discriminant, b squared minus 4ac, is equal to what? It's equal to the square of negative 3 minus 4 times 0.01 times 400. And this equals what? Well, 4 times 400 is 1600, so this would be 16. That's 9. 9 minus 16 is negative 7. Okay? No zeros. So the graph lies completely above or below the x-axis, or the t-axis in this case. And again, there are no zeros because this is what goes under the square root. This is the discriminant. It's negative. You don't get a real number. So there are no zeros. And maybe I should say no real zeros, because there are complex zeros, and you would want to be able to find those if you were asked for a different type of, in a different context. You might be able to ask to find the complex zeros. But that wouldn't be relevant here. All we know is there are no real zeros. So the graph's either always above or always below the x-axis. Vertex, let's say the axis of symmetry is at t equals negative b over 2a. It might not have been written real clearly, which is going to be negative 3 over 2 times 0.01, which is going to be, and it's the negative of negative 3 over that, and that's going to be positive 150. So now, if we want to do the graph, here's our t-axis, and here's our y-axis. We know that we come out to 150 here, and the axis of symmetry is going to be here. So the parabola is going to be something like this, or maybe like this. Of course, it won't come up through the t-axis, because then you'd violate the fact that there are no real zeros. So we have to locate the vertex and figure out whether the parabola is opening upward or downward. Okay? So to find the vertex of the graph is going to lie on the axis of symmetry. All I've done is I've plugged the t-value into the equation of the function. I get this. 150 squared is 22,500. 0.01 times that's 225. It's going to be minus 450, but plus 400. So it's going to be, I think, 175. Now you have to check my arithmetic on this, because I'm not being all that careful. I haven't figured these out in advance. But this tells us that the vertex is at 150, 175. 150 seconds, the water is at 175 millimeter depth, or whatever the units are. We also know that the y-intercept is what we get when t equals 0, just as the t-intercept is what we get when y equals 0. So if we plug in 0, we get 400. So we have the point 0,400, we have the vertex, and now we can see how the parabola is going to look. It's going to come down kind of like this, going to hit its vertex, and it's going to go back up. Now, of course, the domain is going to not include this part of the parabola. So we exclude that from the domain of this function, because obviously if water's flowing out of the thing, through a hole in the bottom, it's not going to spontaneously refill. Okay, so here is our quadratic model, and if the model applies starting with some value of t, maybe the thing starts at, t equals 15. Then this section of the parabola would correspond to our actual depth versus time model. Okay, so there's the graph, and here's how we use the quadratic formula. And we note that the negative b over 2a that we got here is just the negative b over 2a from here. And we've explained how negative b is halfway between negative b plus this thing and negative b minus this thing. And by symmetry, that then has to be the axis of symmetry.